Hey everybody, we are here once again. This is Sean and this is our Director of Education, Olga, with the Hands-On Science Center. Thank you so much for joining us for our very next kit. This is our density column kit, isn't it?
It is, yep.
All right.
It's really fun. It's going to be a lot of fun, and we're going to have a lot of different liquids and fun stuff to look at.
All right, well let's go ahead and dig into our kit and see what we got. Of course, we got our booklet. This is a very bright and colorful one this time. I have a feeling we might make a colorful project.
Yep, with all different colors of the rainbow, almost all of them.
We got a little plastic bottle there. And a pencil, and then a bunch of little containers. We got some liquids in here. We got one, two.
We'll talk about each one.
Got
Each
a red
liquid.
one, blue, a clear
You're
one.
right about saying it's colorful.
Yeah, this is very colorful. And all right, so it says density columns. So I guess the main principle we're talking about today is what?
Is density.
Makes sense.
Right.
So what is density?
So density is the measure of how much mass you have in a certain volume. So what mass means is how much stuff you have in a certain object or liquid, and then what volume is how much space a certain liquid or an object takes up.
Okay, so I guess you probably have seen, if you had like a styrofoam ball like this size, and you had a rock the exact same size. Now, one's going to be heavier than the other, but they're the exact same size. So is that density?
Yes, it is. So your heavy rock would obviously weigh a lot more. It's got more mass, more stuff in it. So that's going to be a lot more dense than your light styrofoam ball.
Gotcha. Okay, so really that's the simple concept that we're talking about today.
Exactly.
And I think we're going to do something really fun to demonstrate how density works. And I have a feeling, based on what we got here, that we're going to be talking about the density of liquids.
Exactly.
And then we got this empty bottle. So let's go ahead. Very first thing, you want to turn to this very first page here, because there is a little pre-quiz. And tell people why we like to have them do these little pre-quiz.
So we like to see all the viewers, all the kids at home that are doing the project with us, just what they already know. So the idea is we would like for the kids at home to learn a thing or two about our lesson, about our fun project, just so you know that not only they're having fun, but they're learning something as well. So it's totally okay I believe we have 5 questions, and it's okay if you don't know all of them or if you don't know any of them. I don't know is a perfectly good answer, because that just means that we'll go through the lesson, do our project, and hopefully you will learn what the question is and you will get the answer to it. And also we want you kids at home to learn a thing or two about science. So if you can, as you fill out your pre-test and post-test, we would like it if you could give them back to us. You could send it back, or next time you pick up your next kit, just so we could know that at home the kids are paying attention, and not just paying attention, having fun, but also learning as well.
Yeah, you can even take a picture of the pre and post test and send it to us, either email or Facebook.
Exactly.
These are actually really important because we actually use these numbers when we apply for grants and things like that. So knowing how much we're teaching will be very helpful to us. So we're going to dive right in here. We're going to just kind of, it says make a hypothesis. So in science, I think we need to make a hypothesis first, right? So what does hypothesis mean?
Hypothesis is a fancy word that scientists use for making an educated guess. So kind of making your observations, even before you start your project, what do you see, and making a prediction, and then seeing if your prediction's right.
All right, so it says here to take a look at our cups. So we're just going to start observing. Observations, like you said, very important in science. So even shake them a little bit and see. And then we are going to try to guess which of these liquids is the most dense and which is the least dense.
So what I think is really cool about this project is usually when you think of something having mass, having weight to it, you don't really think liquids. I always kind of assume a liquid's a liquid, it pours the same, but really, if
Yeah.
you take all of these,
Well, this one right here, I don't know what it is yet. I haven't looked and seen what it is yet, but this one, it seems to be really thick.
this one's kind of thick too,
And
the
it's-
red one. Mhm.
It's heavy. Now, this one seems to be a lot heavier than this one.
All right.
So shake them. And then, like I noticed, when you kind of shake this one, pour it, nothing sticks. But then a couple of these, it's actually kind of sticking to the sides, especially this brown one.
Oh, yeah. I noticed that too.
All right, so then it says, make a hypothesis on which liquids listed on the next page under materials. All right, so we got, one of these is vegetable oil, one of them is water.
Which was
All right, and then we dyed that blue, it says, so there you go.
Yeah, we dyed them all different colors. Well, not all of them, actually just two of them. So you could see the different contrast of the liquids when we do the density columns.
So then the clear one, it says isopropyl alcohol, that's rubbing alcohol. Red is glycerin. This dark thick one here, the dark brown, that is corn syrup. And then green is dish soap. All right, so we got those six. We got 6 lines here. We got to try to write down right here the first one that we think is the most dense, and then, or first one that is least dense, and then the last one here that is most dense, and kind of write them in order. So using your good observation skills, we want you to look really carefully at these and try to figure out if you can write down the correct order. And that is going to become our hypothesis for the rest of the experiment. So go ahead and hit pause right now. Take your time, shake them, get really good, be a good scientist, and look really carefully, and we'll be back with you in just a second. All right, we are back. We kind of, I wrote down my guesses here on my hypothesis, and now we're gonna start doing the procedure here. So it says, start with your column, you know, the density columns is what we're making. And we're going to learn why they're called that in a second. But so start with this, and then pour the Caro dark corn syrup into the bottle. Now if you look back up at your materials, at the colors, the corn syrup was the brown one. All right, so I'm going to give that a shot. I'll take the lid off here. All right, so this is my corn syrup. Now, it's a little sticky. If you're doing this at home, it might be a good idea to have your parents put out some newspaper or some place that's really easy to clean just in
Roll my
case you
sleeves
spill.
up.
Yeah. All right, so it says just go ahead and pour it in. It says, now with this kit, it's really important that we kind of pay attention to it carefully though, right?
Exactly.
All right.
So with some of these steps, some liquids you have to pour, well, not only slow, but slower, and you have to pour them right in the middle. So for this first one over here, we are going to pour the liquids carefully into the center of the bottle.
All right, so I'm going to try not to get it on the sides at all.
Make sure the syrup does not touch the sides of the bottle while you are pouring. It is important to let each layer settle before adding the next one. Take your time and pour slowly and carefully. Now if you get a little on the sides, it's okay because we all make mistakes, they're all not perfect, but try your hardest to have it in the middle.
I got a little tiny bit there, but that's okay,
That should be
it's
okay.
fine. Now, like she said, between these layers, you want to try to let them set for a bit. So I just got a little teeny tiny on the side there, and if you look really carefully, my layer is nice and flat. So I think I'm ready to move on. If you need to pause for a second, let it get nice and smooth, that's perfect. This one, a lot of real careful work and a lot of patience necessary. So step 2 is
And
what?
next is the glycerin. So that one is
Okay.
the red
The
cup.
red one.
We went ahead, add food dye to your glycerin in order to see the contrast of the layers. Again, try not to have the glycerin touch the sides of the containers. So you want to pour it very slowly and evenly right in the middle.
All right, so very slowly, because I have a feeling if I just dump it real quick, it might get mixed in there or
It
something.
might. And it might separate, but still it wouldn't make those beautiful layers how we want them to.
All right, so I've almost got it all. I'm gonna go for a little second here. Now it's not necessary to get every drop of these containers out. I mean, you can see my corn syrup, you know, it's so thick, a lot stuck. So it's not completely necessary, but actually,
You
go ahead
can
and
already
look.
start seeing a layer. So
Yeah.
the brown and red kind of look like the same color almost, but you can see just the consistency is different. Like the glycerin's very clear, and the dark corn syrup is kind of more opaque, it almost seems like. But you can definitely see those layers.
Now, I have a feeling the
Very
colors, like we said, we need to let it sit. So I think the colors might even separate a little bit better. But
It's a good hypothesis.
yeah. So once again, if you need to pause and let it sit, you can. But I think I'm going to go ahead and move on.
All
So what's
right.
the next one?
So next one, we are going to repeat the same procedure with dish soap. So this is the green cup right here.
Okay.
Pour directly in the center of the bottle without touching the sides. Take your time pouring. We cannot stress this enough. That's how you get rid of
Nice
those
and
nice
careful and
layers.
slow. All right, I'm almost done there. There we go. Let's see. Oh, look at that
Oh,
layer.
cool.
Now mine,
Wow.
you can see it's got a lot of little bubbles though. You see all the little bubbles there?
Yeah.
But again, it doesn't matter. And I'm going to say it again, if you want to go ahead and pause and let it rest a little bit, you can. Now, the slower and more patient you are at this, the better result you'll have. And I will tell you, we'll talk about it again at the end, but we are going to have a little contest where you guys at home can actually win a really cool prize from the Hands-On Science Center. So the slower, more patient you are, the better your project will be. So what is next?
Right
Because
now-
I'm not patient.
We have to be for this project though. So next is the blue water.
Okay.
So we added it to be blue so you can
So
see
now-
the different contrast.
It's just regular water though, right?
Just
like
regular
right out of
water.
the sink. Okay.
Yes, with food color.
All right. So I got the lid off here. Now this one, do we do in the center or down the side?
So
or-
now we are going to let the water slowly trickle down the side of the container to create your next layer. Take your time.
All right, so this is very important because now we're changing how we do it. Those other ones we want right down the center. This one you're going to kind of very, very carefully tip your bottle sideways just a little bit, real slow, and then start trickling your water down just like that, real, real slow.
This one might be a little bit trickier just because that water seems to be pouring a lot quicker.
So slow as you can. All right, I'm getting towards the end here. Going nice and slow. Now remember, you guys all know at home what happens when you mix, soap and water. Remember that green is the dish soap. So we want to be real gentle because we don't want to get that, sudsy or anything. So I got like that. I'm going to very slowly tip it back up. And look
Wow,
at that.
look at that.
That is really cool. Now you can
Awesome.
see, I don't know if you can tell on camera, but there's a little bit of the greens kind of swirled in there. But now this is where it's important that you go ahead and let it sit. I can already see it starting to fall down. So I'm going to try and be patient, and I'm going to let mine sit for just a couple minutes. And you guys do the same, and we'll be back in just a second. All right, we are back, and mine is starting to settle very,
wow.
very nicely.
That looks really
Got
good.
a little bubble still, but it's looking really cool so far.
Yeah, absolutely.
All right, so just a reminder, we got the corn syrup, then we got glycerin, dish soap, and water. So let's go ahead and just start thinking for a minute, because this is science. We're not just doing pretty art. Now those on the bottom are staying separate.
Yes.
And then we got our water. Do you know water can float? Look at that, the water.
Apparently it is.
is
Yes,
floating.
it's floating.
So what is starting to happen here, Olga?
Well, it looks like our liquids that are on the bottom are the most dense. So they have the most mass per volume. And then as we go higher up, the higher the liquids are, the less dense that they are.
All right, so what is the next step? What's the next liquid we're supposed to use?
So next we are going to do vegetable oil. Let the vegetable oil slowly trickle down the side.
So that is our kind of pale yellow one.
You know, you always think of water being so light. At least I do. I would.
Yeah, now wait a minute. I don't know if you can see those drips. It is not dripping like water. It's a lot thicker.
It is.
So I wonder what's going to happen here because our corn syrup was really thick
It didn't drip, it kind of just.
and our water was really thin. But the corn syrup is more dense, so it's at the bottom. So I don't know. Did we add them in the wrong order? Because now we added thick liquid. Or by thick, I mean the scientific word is viscous, right?
Yes.
So that just means it pours really slowly. So we added a thick liquid, or 3 kind of thick liquids, and then we added a thin liquid, the water, and now we're adding a thick liquid again. So, ooh, I don't know, maybe we did it wrong. Let's try it. All right, so just like with the water, we're gonna very carefully tilt our bottle, and then very carefully pour it down the side.
I'm very curious what's going to happen with this one.
Nice and slow. Oh, you know what? I can already see a layer starting to form.
Oh yeah, that's a very distinct layer.
Yeah, that's a strong layer compared
Wow.
to some of the other ones. Here we go. I'm almost done. And very carefully back. And there we go. Wow, look at that one.
Look at that.
So you know what? We actually just made a very important discovery. I can't remember the questions, but I think it might actually help you on your little quiz there. Now, does thickness, or do you remember the important word, the big science word for kind of thickness of a liquid? What is it?
Viscosity.
Viscosity. So, does the viscosity, or how thick the liquid is, affect the density? And apparently,
It looks
no.
like, no, it doesn't. I'm not gonna lie, I thought that the vegetable oil was a lot thicker than water before we started this project. But if you see the layer, it's a very strong layer. It's not really,
yeah, kind of our green
it's
and
not
blue
mixing into each other. The green and blue,
mix slightly.
a little
And
bit.
then the red and green mix slightly, and the brown and red mix slightly, but that one right there between the yellow and blue, that's a sharp line.
That's a sharp line. I feel like, I don't do it. Maybe you can at the end if you want to, but even if you were to mix it really hard, I predict that it would just separate immediately.
Yeah, so
Who knows?
that makes me think of something.
That's really cool.
I mean, very often it's really terrible, but there's like oil spills and stuff like that out in the oceans. And I think that this factor is maybe one of the reasons why they can be so bad, because is that oil and water mixing?
No, it's not mixing at all.
That's why you see the big black, if you see on the news, big black slicks of oil, because that oil is actually floating on the water, right?
And also you have to remember that water is seawater, usually like in an ocean. So with ocean, it has other minerals and salt in it, very, very salty.
Wait, you said it has salt in it.
Uh-huh.
Before you said more stuff in something means it's more dense. So actually, if we were to use salt water, would it be above? I'm asking you guys at home, if we were to use salt water, would it be above or below our blue layer? I don't know, let's think about that. And I don't think we even need to give you the answer, because you learned a little bit ago, the more stuff in something, the more dense it is. So, but I think that, is a really cool thing we learned there.
That is really neat. Well, let's move on to the last liquid we have.
Last liquid, that's
Okay.
the rubbing alcohol, or
Yes, isopropyl alcohol. So similar to vegetable oil, we're going to pour the isopropyl alcohol very slowly down the side.
All right, so we got our very special slow motion tilt going. And then I'm going to start adding the alcohol. Couple more drops. There we go. Well, that did make a really good layer too. Now when I poured it, I got my my water layer and my oil layer mixed up a little bit. But again, you know what it means? It means it's time to hit pause once again and join us in probably, 2 or 3 minutes, and we'll see how it looks. Alrighty, so we have been letting our column, our density column here, sit for a little while. You go ahead and get this stuff out of the way, clean up here a bit. Now, that
That
looks really cool.
Yeah.
And I have a feeling we let it sit for about 5 minutes or so. The longer you let it sit, undisturbed, want to try not to shake it, the better it'll be. Oh, you know what? I think I forgot something in the bag. You might want to now screw on your lid. Just kind of push it over there and then twist. There we go. So that way we don't knock it over and spill it all over your
That'd be
parents'
really
carpet or
messy.
anything like that. Yeah. Well, it has dish soap in it, so it's self-cleaning.
And then vegetable
Yeah,
oil.
I don't know.
Yeah.
All right, so let's go back in our book here. We're on this left center page here. It says data and observations. So earlier we made some observations when the liquids were still in the containers here. We looked at it and kind of decided are they thick or thin, and made some guesses. So now we're going to do some more observations on our finished product. So it says, what did you see? So that seems pretty straightforward, but what kind of things might they look for, and what do they want to write down there?
So they want to look at the liquids and the layers and see, are some very clear? Do some have bubbles in them? Are some more opaque, like you can't really see through them as well? And also, it's okay to give your bottle just a very light tilt to the side and bring it back. And as you can see, some of those liquids, when you do bring them back, they don't make that very strong, distinct layer, and they almost look like they might mix into other liquids, like other ones.
Kind of look like like little waves even then, but then
Exactly.
they start settling slowly again. All right, so go ahead and write down your observations there. And then for the next part it says, what was the most dense liquid? So that's what we made the hypothesis about earlier. If you turn back, you should have made a little list of your hypothesis of which ones were the most and least dense. So now we're going to know what the answer is. So
the most dense in our project, it looks like, is the dark corn syrup that's all the way at the bottom.
okay. And then
So
so
it's
the
got-
least dense would be,
The least dense would be the rubbing alcohol on top.
there we go. And then shows the layers. So it went the corn syrup, glycerin, soap, water, oil, and alcohol. So now go back, look at your hypothesis, and see if that happens to be what you wrote. And if it is, great. If not, doesn't matter. Because, do you think scientists' hypotheses are wrong a lot of the time?
Oh, yeah.
They are.
course.
Yeah, I mean, if you just always got it right, there's no point in testing. So most of the time, the hypothesis doesn't come out exact. But we want you to go ahead and compare what you write here, and that should be the list of it says, list the order you poured the liquids and compare it to your hypothesis and see if they match. Very neat, just like a scientist does. And then the next question, what keeps the liquids separated? I think you should be able to figure that out by now. So go ahead and write in what you think there. And then what happened when you added the rubbing alcohol. Again, we don't want to just give you outright answers. So put in what you think there. And why do you think that happened? And then down here at the bottom, there's a little, we're going to test your knowledge on density for some of you older kids or whoever wants to give it a shot. There's a little tiny quiz there talking about density between two different materials. So you can try that out if you'd like.
Little math problem.
And then let's see, on the next page here, it says scientists often change variables in their experiment. Olga, what is a variable?
A variable in science is something in your experiment that can be changed, or you can make changes to. Something that could be manipulated, something that you could remove or add on to. So in our situation, or in our experiment, our variables are the different liquids that we put in.
What about the order we put them in? Is that a variable?
Yes, exactly.
Okay.
So how we manipulate, how we do the order of our project as well.
So it says, what would happen if we added another liquid, if we poured something else on top? Who knows? Yeah,
You don't know?
we gotta test it and see. This is a good one. We changed the order. Now, we added them in a certain order, what if we mixed up that order and added them? Think about what you think might happen if we were to do that. Interesting. All right, and then the last thing it says here is some different liquids, list some different liquids you might want to test next. Oh, that's really cool. We did this, but hey, maybe you want to do it again someday. So you can list different types of liquids. There's a little picture here that has a couple extra that we didn't use, but you can go ahead and list those and then guess how their density compares to these. There's even like milk, it says on one of them that they used.
Oh,
and
wow. I
honey.
wonder what that would look like.
See, yeah, actually this picture, it's got maple syrup, corn syrup, and honey. And it actually looks like those all have different densities.
Those are
Pretty
usually
neat.
like, they're very thick and a lot of very viscous. So that's really interesting to see how those three would compare to one another.
Yeah. So then, you know what? It's time for the post quiz. All right, so now you're going to do that last green page there, and you're going to try and see if you guys learned anything. So this was a lot of fun, Olga.
I think so too.
And it's pretty. You know,
Yeah,
you can go
it's-
just set this up on my shelf at home and look at it. Unless I come by and shake it or something like that. But very, very cool. Thank you so much for watching. There is like a little hint for our next kid in here. I know we've been working on that one. It says bird barf.
Bird bark.
What the
That
heck?
doesn't. I don't know what I feel about that. That
Yeah.
might be cool though. I think it's going to be cool.
Yeah, I think so.
I think it'll be interesting.
And then make sure you are tuning in to our Facebook Live virtual classrooms. We do those every other Thursday. Looks like the next one we're going to be doing is the science of flight. So that should be really neat. I almost forgot. The very final step, it says in here, is after you've finished your project, have your parents take a picture of it. And like I said at the beginning, you now have a chance to win a really cool prize that Olga and I are going to put together here for you. So have your parents take a picture. And then on the Sunday after we release this kit, we are going to be doing a special Facebook post that's called HOSC Take Home Science Show Us Sunday. And we want you guys to show us what you did. So we want you to take a picture of this, have your parents post it in the comments of that Facebook post, and whoever's picture gets the most loves or likes is going to win that really awesome prize we're going to put together. So definitely please make sure you do that. The other cool thing, yeah, you can win a prize, but actually, believe it or not, doing that kind of stuff helps us, doesn't it, Olga?
It does, yes.
The more likes that our posts get, the more people find out about these programs. These take-home science kits obviously are kind of for our local Tullahoma area, but we have our Science Daily posts and our virtual programs that we do, the Facebook Live programs. Those are actually being seen nationwide, and it's because people comment on the posts and share them. So please make sure you post those on there. Make sure you like the pictures. That is the biggest way to help us out. If you can help financially, all this stuff we're doing is 100% free, so feel free to go to www.hosc.org and click that donate button. That'll help keep these programs free. We got a little bit of them that we have some money for, but we're not going to be able to keep this up. So we need help from you guys in whatever way you can, whether it's financial or just liking these posts, getting the word out. I really love doing these. I know that
I think they're a lot of
great.
fun. And we just like, we really encourage the kids at home to do take those pictures and send them to us, because we love seeing the kids get excited about science and get excited about our projects and learning a thing or two. And even if your layers may not be completely separated and you may have made a little bit of mess ups, you may have spilled a little on the side, that's okay. We want to see those pictures as well.
Look at that. That's cool. This was fun. I think I'm gonna just sit here and play